Welcome,
Hello.
everybody. Hello, Adam. Hello,
Yeah.
Marcel.
Hello,
Today
everyone.
on our show, we have Marcel Fóti, who has written a book called The Natron Theory, and he's really been opening a lot of people's eyes on X for quite a while now. I first found out about you, I think, about a year ago, Marcel, and very interested. I'm fascinated, and now, I see a lot of things everywhere since you've opened my eyes to all the
Mhm.
things you've been doing, but. Um, I'd like to get started with something simple and just ask you for a lesser known fact about you that might surprise our listeners, just so we can get to know you a little bit.
Okay, so yeah, what's the concrete question there?
Oh, yeah. What's a lesser known fact about you that might surprise our
Oh
listeners?
my. Okay, any fact.
Yeah, any
Okay,
fact, just something fun.
so maybe the most surprising is that I'm not a scientist at all. Yeah, I used to be an IT guy for decades, and
Oh.
I was lucky enough to sell my company. I was bored, like
Hmm.
hell, and I had a lot of time to do something else, and this is something plan B or side B of my life,
Right.
playing with these stones, and I'm just very lucky to bump into this one, and
Mm.
that I have real successes is just mind blowing for me. I'm learning some new thing every day, each and every day, and there is a eureka moment for each and every day. So it's fascinating, much better than IT.
Yeah, it's funny that you mention IT because Adam works in IT. I had an IT business with my wife and we sold it. We got bored. So,
Right.
we haven't been working for anybody in the past year, but we've just been enjoying life and doing all kinds of things. And that's amazing that we have three IT people here. It seems like IT people are very curious about a
Maybe,
lot of
yeah.
things.
Or IT is boring after 20 years. It tends to be boring. A sequel
Right.
again. Okay. Select
Yeah.
star from. Okay.
Yeah. Adam, you've been in IT for how long now?
Call about 15 years or
Yeah.
something like
So,
that.
yeah, we've
Over
all been in
various
there about
things.
the same amount of time.
Yeah, it's been a long time.
I'm not telling there is nothing new because AI is definitely new, but
Yeah.
okay.
Yeah.
Yeah.
um, so you know what? I wanted you to give us a little bit of background on how and why you got started on the Natron theory, as far as like your experiments, like what
Okay.
drove you to that, and how'd you get started? For everyone that's maybe in IT and doesn't know anything about science, like you said.
Okay, so it's easy. When I sold my company and we were free with my wife to travel, COVID hit, and whoops, everything was locked down, so
Mm,
we couldn't.
Yeah.
So basically, my plan B was to watch YouTube videos about traveling. What else? We were locked into the house, and I bumped into these guys dealing with ancient mysteries like Graham Hancock and
mm.
Uncharted Dix and Jeffrey Drum and Jeffrey Drum. Do you know this guy Jeffrey Drum? You should.
I don't know that
I don't
guy. I
think
don't
so.
think.
He's
Some of
he's
the others I heard.
he's brilliant because uh, what he did is similar that I did.
Mm,
That he came up with a theory, a wide theory, and tried to find where this theory can be wrong, and it was not wrong at all. For example, I was in Egypt 3 weeks ago, and I was checking if this guy Jeffrey is right, because there is the Red Pyramid, and
mm.
it's awfully smelly in the third room. It's king's room, queen's room, whatever's room. The most the inside room is so it's so smelly. It's ammonia. It's like pee.
Oh, wow.
And
Okay.
and and the official explanation is that, oh, because of the bats, but there are no bats, and
Yeah.
this was
It
no,
doesn't sound right.
zero. So and Jeffrey went to the next into the next pyramid, which is the Band Pyramid. Went in there. I was there also, and there are bats in there, but no
Mhm.
smell. Wow.
Ah,
And that that was the first step for him to think about the source of this smell, and he come up with the idea that it's not pee, it's chemical, it's ammonia, and maybe the red pyramid was used to produce ammonia on an industry level. And
Right.
and the story goes on. I suggest you to do an interview with him. But this was mind-blowing for me, that this guy knows nothing about history like me. Maybe he's an IT guy as well. I mean, who knows?
Yeah.
And
We're taking over the world is what's happening now.
Yeah.
yeah, and he came up with this wide theory, and finding bits and pieces of evidence everywhere as he checks whether it's true or not. Okay, I need this. That's fascinating. And I was just randomly picked one mystery. This was the scoop mark mystery at
Oh
the
yeah.
unfinished obelisk in Aswan. These depressions on the top of the carved obelisk. And I told myself I will solve this one. But I didn't know anything about chemistry, zero. So my first approach was to do it as modern humans do. How do we cut granite? And we cut it with just water jet, plain tap water. But
Yeah.
the pressure is so high that the water would cut it. Okay, how to build a machine with this water pressure using only caveman tools or ancient Egyptian tools. And it turned out it's impossible. I'm not going into details. It's just
Yeah.
dumb. It's a dumb idea.
Yeah.
But
No, yeah, like a
meanwhile,
lot of the things they told us over all of time, it doesn't make sense.
yeah. But meanwhile, one of my friends had a piece of stone from the Great Pyramid of Giza, like this size. And somehow we ran into Joseph Davidovic's research, and he told that the stones of the Great Pyramid taste salty. And this friend of mine had a piece of stone, and we tasted it, and it was salty,
Oh,
which is
wow.
strange because limestone is not salty. Even if it gets created under the ocean, it's not salty because it's pressing out the water, and table salt, sodium chloride, is going with the water. So there is no table salt in it. But this was salty. And this showed me that maybe the solution to these depressions is not physical force, but there is something to do with chemistry.
Okay.
And I really don't know how. Wait a minute. I found a webpage, I guess, where they mentioned that one substance, natron, is, if heated to its melting point, is eating quartz. And this was a click moment. A tick. Okay, what is granite? It's
Yeah.
77% quartz. And
Right.
I have this natron, I don't know what it is, and it will dismantle quartz. So basically, natron will dismantle granite. Let's do it. So I went to the nearby shop, bought this natron stuff. It's everywhere because it's a detergent, so you can buy it.
Oh,
It's
okay.
a green detergent. Okay.
Mhm.
And I tried to heat it to 851 degrees. I didn't know if it's possible at all. But I did an experiment with a charcoal chimney. When you light the charcoal for making a grill party, put the charcoal in, I put a tin can in, I put some spoons of natron in it, and put a piece of red granite, light it, whoop, let it burn down, and ta-da! My piece of granite was edged badly
Oh,
after
okay.
when the charcoal burned
How
down.
long did that take?
20 minutes, 30.
Okay.
It's not that time.
Right.
It's
Yeah.
nothing, just nothing.
Hmm.
And it was just fascinating. For the first try, come on, why for the first? and no one knows about it. Okay, it's not true. As it turned out, a lot of people knows about, but not in archaeology, because
Okay.
people who try to recycle metal from chips and electronic devices, they use natron to remove
Uh,
the silicon, yeah,
yeah,
and
to break it down.
yes, and get back the metal. So they know it. but nobody knows in archaeology.
Mm-hmm.
Anyway, I was able to etch a piece of granite, and the material on it, it's like salt, because it's a salt, and different salt. And I googled for it what it is, what's the end, what's coming out of this reaction, and it was so-called water glass.
Okay.
And actually, I didn't know what is water glass, so I have to Google again.
Mm-hmm.
And I found that this is the main component of modern day geopolymers. Wow. And geopolymers are artificial stone. Wow. So if you etch the granite, you end up with a substance that you can create stone with it.
Mm-hmm.
Oh, is it possible? Am I dreaming?
Yeah.
And and it's like that. So I have this small guy here, this one. This went through
That's what I first saw from you.
That went through the whole. Most of the time, I buy water glass in a shop because it's much more easier than etching the granite. But this guy was created to do the whole cycle, etching the granite, removing the water glass, make a solution of water glass, adding back the gravels and some wood ash we needed.
Mm-hmm.
And I know this guy is the one because I pushed a battery in his body, you see?
Yeah.
So he is the one.
Uh-huh.
So full
and
scale.
those are the Moai statues, right? That you also believe are cast as well, correct?
Sure.
Yeah.
Why to bother with chiseling?
Yeah.
When you can cast any shape or form? Yes.
So I've been to Easter Island, and we went through the whole island, and we saw where supposedly the manufacturing line was of where they were carving it out of the mountain, and they're all in different stages and everything.
Mm-hmm.
Have you been to Easter
No,
Island yet?
I haven't, but it's okay. It's okay that somebody else, some civilization was carving statues there, but this doesn't prove that an earlier civilization did the right thing, casting.
Yes.
What? Oops.
Oh.
Okay.
Mm-hmm.
What proves it is again Mr. Davidovich, because he analyzed these stones on Easter Island and found organic material inside the stone.
So you're saying there may have been some carved and some that were cast?
It happened. If you run out of the source material, you cannot cast anymore. So yeah. So
and if Marcell or George, if you'd like me to share other things, I can, or we can pull it down. I just thought it might be helpful to kind of walk through this. I can be your resident scribe.
There is a strong evidence that these statues contains bird poop. How on earth?
Yeah.
Very nice.
So the scoop marks, let's tell us a little bit more about the scoop marks and like why are those clues for everyone? Like let's say someone's just on a trip and they go to some ancient place and they're looking they want to look for scoop marks, and why is that? Like I know, but pretend like nobody knows anything.
Okay. Let's find scoop marks everywhere on Earth first. So if you do Google for Stonehenge stone 59, maybe we will find it. I have a photo of it, but let's try this.
Okay.
59. No, that's a dumb search. I have can I share my screen?
Yeah, sure.
Yep.
Okay.
Of course.
Where is it? Just a sec. Okay. Albums. Oops, wrong direction.
Yeah, it's interesting while you're pulling it up, Marcell. I looked at some of your other content, and it's amazing how many different applications there will be with casting. And I know you even mentioned, you might talk about this a little later, how modern day concrete is not what concrete or castings was back then. Actually, the water, you're able to pour it out into old concrete, I think, and that's part of the shapes and everything.
Screen. Oops, what happened? So this is this on the left. I don't click on it because it's a small picture, but this is you can see that it's in Stonehenge.
Oh,
yeah. And this is stone 59, and and it has this beautiful scoop marks on top of it. And there is another example. I think I can zoom this. Oh, this one. This is from Peru. In the middle of a river. This is very nice as well. And this, what is this? I think it's Peru again. Okay. It's not.
So on the scoop marks, are they using something to scoop it out, or is that just from settling during the casting
It's when you do the chemical reaction, there will be a layer. This is Barabar caves, and the people are always looking the caves, but if you turn the other side, you will see the scoop marks here. Etching. So when you do the chemical etching, there is a layer of water glass on the surface, and you can remove that and put it in water to create a liquid. This one is very nice. This is Sigiriya. It's Sri Lanka, and it's not. This is not the stairs. It's the stairs are on the right. These are scoop marks creating water glass. Why here? I don't know, but it's there. So
yeah.
So the first, to answer your question, the first answer is that it's everywhere, and I don't think you need an outsider, a teacher, to teach you this, because if you are playing with fire, you will definitely find out if you are curious enough.
Yeah.
A better question is why we don't know it. Why this civilization has no clue. All the others, the old ones, knew it, as you can see.
So do you think it's because everyone is so, I guess, trying to be an expert in one area or another that they don't cross different, maybe modalities or other experiences?
Sure. Could be. But when this phenomena started 200-300 years ago, and we are here for a millennia, and we have no clue.
Yeah.
Right.
Yeah.
I wonder. Yeah. I want to go first to. I probably think that it's being suppressed on one side because you probably have dealt with archaeologists and you see like they are so close-minded, it seems sometimes, or they just are, maybe they're just focusing in on what they know.
Definitely. They don't know anything about the real world. They know how to read hieroglyphs, and that's all, or read text. But
it's chemistry, like you said, right? Like,
but it's basic, it's elementary school chemistry.
Yeah.
Huh.
Is that something that you learned over there in Europe? That basic chemistry over there? Because I don't, personally, I grew up in Texas. I went in the United States. I don't remember ever having that in chemistry class, like unless I forgot, right? But I just don't remember.
I forgot everything. So I know what the periodic table is, but I didn't know any elements. So maybe So this is. Now, let's not call it elementary school, but basic. It's easy to do. It's not. You don't need a plant. You don't need anything. You need a kitchen and a fireplace, and you can do that.
Yeah. Do you want to kind of give everyone so this is some basically home science, right? Home chemistry that's safe and simple to do. Like if someone was going to do this outside in a fire pit, could you walk us through what the steps would be so that people can understand how easy it is?
Yeah, it's easy. The heat can be achieved with simple charcoal, and that's it. And the trick is to put natron and your piece of red granite inside the ember. Because if you try to use it on a surface, it's a different story because the heat escapes. That's why my first try was successful, because I put the ingredients inside this charcoal chimney, and the ember was around, so the heat was trapped. So that's why I reached 851 degrees, like like reaching 88 miles per hour in.
Yeah, right. That's
Shit!
right.
Right.
Yeah,
Right.
it opened a door for your mind to see something different that, like you said, a lot of people don't know.
Yeah. Yeah. To be honest, I still cannot create scoop marks like this. I'm
Okay.
still fighting with the heat problem, but there are clues and tricks and dirty tricks to bring down the heat. Just one example. It's a
Yeah.
month old story. If you go to Peru and you burn quinoa, the plant,
Oh,
and
quinoa.
you
Okay.
quinoa, yeah, and you collect the ashes of the quinoa. It has two components, both etching granite. One is sodium hydroxide, sodium oxide actually, but you will water it, and potassium oxide. And if you wash this quinoa ash, you will get sodium and potassium hydroxide, and with this mix we'll have a melting point of 150 degrees only. So not 800, but
Yeah.
Right.
150.
150.
Oh
Yeah.
my God, it's 600 degrees Celsius lower and still
Yeah.
etching granite. I'm not telling that this is what happened, but
Yeah.
it's a way to think about that. Okay, maybe there are some modifications that you don't have to reach this high, because this
Right.
high is a challenge if
Right.
you use it uh, not in a closed system. In a closed system, it's okay, but in open, it's a challenge.
Right. A large methalithic structure would be the
Yeah,
challenge as far as that temperature.
yeah.
Okay. Yeah.
So I want to ask you, moving a little bit more towards your book creation, like what I'm sure since the beginning, everything that you were doing, you were probably taking notes because you were going through all the experiments and the changes and modifications. Tell me a little bit about like putting the book together. Like, how challenging was that for you? I know, I was following you, so I saw what you were posting about going through the book. But for everyone that may be watching this,
Mm-hmm.
what was the biggest challenge for you to do the book? What actually even made you decide to do the book?
Mm-hmm. Okay, the best motivator to write a book is deadline. Is a
Yeah. Okay.
good old deadline. The
Mhm.
first step was I set up a deadline for myself, because if there is no deadline, I do nothing.
Mhm.
And the main motivation to write a book was to do everything again. Yeah, as you told me, to
Mhm.
document it and to understand it better. Finally, because when you create something, do something once, and it's successful, you don't understand why it happened. I have a big debate with Jimmy Corsetti, because when I tried to soften a stone, it was working for the first try again, and
Oh,
it's a bad luck because so many variables were there. I didn't know what happened and why, but that was a success. And he challenged me that I cheated. I didn't, but I
yeah.
didn't. But I didn't know all the parameters of that, and it took me
Right.
months to figure out what I did right for the first time.
Yeah.
So writing a book is a it's an outside force on me
Mhm.
to understand it better. And I think, knock knock knock, I understand a lot of things far
Mhm.
better than before.
Yeah.
Yeah. And are you finding that you're getting good feedback from the book now, like the
Yeah,
community that?
the feedback is mind blowing. It's
Mhm.
just so positive. I didn't check for a while, but it's 5 stars everywhere,
Mhm.
and and maybe because I'm not pretending to be a scientist, because I'm not.
Right.
Yeah.
You're just being you.
Well,
Yeah.
you actually are. I'll argue with you there and say you are a scientist because you are doing scientific things now. So now you are a scientist.
Uh,
You
okay.
But not in the traditional sense. You're just
Yeah.
you're going
Right.
off your instincts in the background that you have.
Yeah, and I don't care what. I have no finance institutions above
Right.
me to
Mhm.
tell me what to do and what to postpone. I do
Right.
whatever I want.
Right.
Yeah,
That's a
Right.
great position to be in
yeah.
for sure.
Yeah.
And on the book, so one thing I've noticed, so me and Adam have talked about this before, and I don't know if you've seen it in anything that you're doing, but since I started following you, I've started seeing that there's other people that are also playing with this Natron theory and doing their own things. And one thing that we've noticed is that when someone does something, other people start doing it as well, and it brings more visibility to the subject, because before you I had never heard about this ever,
Mm-hmm.
and since I've been following you now I'm seeing other people that are working on it too, and seeing some detractors. And you've seen me, go to bat for you sometimes, because people will post things and I'll tag you in and say, hey, this is what's going on. But it's just funny now to see so much more of this now. Like I'm seeing
Yeah,
more people talking about
yeah,
this
yeah.
now.
Not only talking but doing, actually.
Yeah,
A lot
doing
of people.
experiments.
And yeah, and what I love about X and doing it openly is that I'm learning a lot from the comments, a lot.
Mm-hmm.
Because, for example, I have a problem right now. I plan to solve it with X and with the community, because I have at least 200 kilograms of wood ash in my basement waiting for me to create a man here. You know that?
Yeah.
But there is one ingredient which looks like it's necessary. It's honey. And
Really?
it's, yeah. And it's not, it's very expensive to 200 kilos or a ton of honey to mix in. Oh my God, no. And
Yeah. And
we
what does
need
honey do?
several things. Uh, Actually, I can show it to you because it's in the next room. Let me show you.
Yeah.
Okay, sure. Yeah, thank you.
Yeah.
That'll be awesome.
Yeah. I'm trying to think of the amount of cost that much honey would be.
Yeah,
But you
honey
have a
is
local
expensive for
beekeeper.
sure. Like you'd have to be a beekeeper and all of a sudden just to get your own honey going.
Right. But then I'm thinking the application in ancient times then too. How much you'd
Yeah.
need that for.
I bet honey was more available. I'd have to look this up, but I bet honey's more available way back when.
Yeah.
So there is this guy. It's
Mm-hmm.
flawless. It contains 20 grams of honey.
Mm-hmm.
But
Okay.
this one, you will see, it's not flawless, but it has a a white powder in it. It's called efflorescence. Basically, it's giving back natron. I don't want this natron, but it's
Yeah.
coming out from the
It's
stone.
releasing it out.
Yeah,
Okay.
and honey will stop this. And there is another guy here who is bubble face, full
Yeah.
of bubbles,
Uh-huh.
and the difference is just honey. So if I put
Wow.
honey, the surface the surface
That's an
is,
amazing difference.
yeah, between flawless and many
And
bubbles.
do we know what the honey's doing chemically, or why that works,
I
or
don't
like
know.
we
I
haven't
don't.
figured that out yet?
It was an idea from a guy from Australia who tried to replicate my
Uh-huh.
results, and we tried a lot of things because
Mhm.
it is a strong stone. But come on, it's not
Yeah,
good quality. It's not.
that's right.
Right. Yeah. I just to your point, George, I'm wondering what derivatives are within honey, or if is it really just the magical structure of what honey is that works the best. So Marcell, you're saying that's the one that actually created that really smooth, almost polished like exterior.
Yeah, this fake basalt is the same wood ash and water glass.
Yeah.
You say it's from, it looks like basalt and it's hard as basalt, and the only difference is some honey.
So no polishing, no
No.
sanding, nothing.
It's just
It's just
out from the
living
silicon.
in the honey.
It's out from the silicone mold, untouched.
Yeah.
No,
Wow.
Awesome. That's
and this
amazing.
one is terrible.
Yeah. Yeah.
So you're needing 200 kilograms of honey
For a ton, for a ton of stone. I would like to create
Wow.
several ton column. I need so much honey.
We're gonna have to figure this out at some point, how to do that.
Yeah. I tried to replace it with sugar, but it's no, it's not the sugar. Not.
Yeah, that'll be interesting to look into honey and see if there's something that even comes close to the nature of honey, because I've never seen anything in my mind.
By the way, I just popped in the mind. Someone told me that someone else found kind of honey particles in some stone, in old
Really?
stone. Yeah, but I don't know.
Yeah. Huh.
Well,
That'd be interesting to look into.
yeah.
Um, so I would want to ask you, like, what's next for you on this process? I know you're trying to refine the process and maybe
Mm-hmm.
do bigger and better things on it, but like, you've come a long way already with what you've discovered. Like, what is like the next thing that you're trying to do
Mm-hmm.
within the space?
Okay, so there are two kind of stones I'm working with. One is the volcanic stone. This is granite and basalt and diorite, and the other is limestone, which is a completely different stone, the white one. And right now I'm working with limestone a lot because when I was in Egypt, I found evidence of casting limestone, but not 5,000 years ago, but was just 2,000 years ago. Can I show you that?
Yeah,
Yeah.
yeah, sure.
Yeah.
That's
Okay.
one thing that you're leading me to where I wanted to go. I wanted to ask you
Okay.
also,
So
like, how the
let's
timeline changes. So that's
let's
perfect.
leave blackish stones behind and go to the white ones. Screen. Oops. Yep. So that is a temple in Dendera. Oh my god.
Hmm.
Scroll. My god. Eh. So here is
I
Egypt.
don't, Marcel. I was while you're looking through that. You've probably looked through all these. I was going down the rabbit hole a little bit of honey and derivatives.
Yeah.
Said agave nectar is possibly the least costly, although I don't know what it's or even maple syrup or agave nectar, the other two. But I don't know how different it would be and if it was anywhere close. And
Uh-huh.
maybe the pricing just doesn't matter. It's still
Yeah.
honey needs to be honey, but
Nectar.
just interesting.
Okay. Okay. I definitely will give a try. This is me in the band pyramid, but I'm not showing you this because several days in Egypt. Yeah.
Yeah.
And gazillions of photos. Yeah, tourists.
Yeah, digital photography makes it easy to take a whole lot. Like I was in the photography for a little while, and then it's like, well, if I take 500 pictures, then now I got to pluck, a few out of here to
Mm-hmm.
use
Right.
for
Mm.
something.
Oh, just one thing. Let me show you this. This is the unfinished obelisk in Aswan, and I realized something that nobody has ever discussed, that the digital cameras
Hmm.
see the unfinished obelisk differently as the quarry. There is a distinct color difference between
Hmm.
Yeah.
the obelisk and the original granite
And
Hmm.
here as well. And I use my iPhone and I use my Nikon camera to do it several
Hmm.
times, and
yeah.
uh, it's evident. You see, this is the unfinished obelisk, and
Yeah,
this is the quarry, and it's a different color. And different color means
that's right.
different
Chemistry.
chemic. Yeah.
Yeah.
Okay, so go back to let's find this
Yeah, that's
rooftop.
right. It's so obvious the color difference, and it
Yeah,
makes you wonder why no one is saying anything about it or
Yeah.
they didn't notice.
it looks like I'm unprepared, but I am unprepared. Where is
Why,
it?
when the colors are different, you're thinking
Ah,
just as a theory, are you thinking, Marcel, that they selected an area and a rock or some type of granite structure, and they're going to then mine out that portion, pulverize it, or somehow turn it here chemically, and then pour it back
yeah,
in for whatever they want to use? And I
yes,
think you'd even the podcast I listened to a couple of days ago with you on it, you'd mentioned you're like, it would make sense to do it this way because if you wanted to choose this giant monolithic place to carve out a stone, and then 6 meters into it, you find a pocket that's weak, and then it basically ruins the entire project.
yeah,
So
yeah, yeah.
why
Uh
wouldn't
huh.
you want to cast it?
Yeah,
So
and there is one thing that everybody thinks there is an undercut under the. What's that? What should I do? Issue picture in picture mode close. What? Go away. Okay.
Mm.
So everybody thinks there is an undercut under the unfinished obelisk, but there is not. None. at the bottom of the pit, it's flat.
Okay.
The undercut is at a different place, like it's in the same quarry but a different stone. There is no undercut there. So this means that the whole notion that they wanted to lift it out from the pit is just wrong. They didn't.
Oh.
They could do the undercut because there are big holes. So the bottom of the pit is flat, and there are several meter deep holes going down. So with this effort, they could undercut the obelisk, but they didn't. They created these holes.
Do you think maybe modern man drilled those holes in there to do the undercut, or you think that was from originally?
It's original. It's original. Okay. I guess it's like it's human size hole, so it's big.
Oh, right. Yeah.
Okay, so this is the rooftop, and maybe I should. And as you can see, there are some patterns on the surface of the stone.
Yeah.
And
looks like there's a lot of pits.
and the shapes are just irregular, like in Peru. So it's a
same thing.
Yeah, Cyclopsian rooftop. Let me show you something else. And what's interesting is that this is better to see these patterns. And just recently, one of my friends realized that this cart route here with this T and the hole is a repeating pattern, because there is this T here.
Yeah, that's right.
And with this hole, and there is another T here and this hole. So it's a step of technology as they created this casting.
Right.
And why can we be so sure it's casting? Because here we are.
There's a depression there.
yeah. There was a cast of.
Well, this makes sense too, Marcel, because it's, if you have a template and you may have wood, or maybe you had something different or whatever, but you're going to just keep moving with that template the entire area long. So of course it would have a pattern.
But wood is not abundant. Wood is like gold, because we are in the desert and you have palm trees, but no real wood to make boards. So when you make a mistake, you don't have the luxury to cut your wood in half, because then you have to go to the other side of the Mediterranean Sea to bring one another. So that's why I think if you make a mistake, you will go with the mistake, and this will explain some of these irregularities.
Yeah.
So that's why I'm playing with limestone, and it's okay. I will show it to you, because there is a recipe that was originally from Joseph Davidovich, which is natron mixed with slaked lime, and it creates a glue, and you just put limestone rubble in it, and you are ready to go.
Yeah.
And he put in some other stuff to make it salty. So at the end, his version is salty, like in the Great Pyramid. But I thought it's too complicated. So there should be an immediate step to invent this. So how do you invent this? And let me show you something. It's top secret. Don't tell anyone.
Okay. You won't tell anybody. That's what I love about Marcel. He's always funny.
Cheers. What is this?
Looks like a shot glass, maybe.
Yeah.
What are we gonna drink? I think I need a shot glass.
So I realized that in the mix of Davidovich, the actual glue is sodium hydroxide, not limestone. Okay. And I tried to cast stones with pure sodium hydroxide, and then with pure potassium hydroxide. And potassium hydroxide is just wood ash soup or something. So you wash wood ash and you end up with potassium hydroxide liquid. And this one is limestone powder down here and
Yep.
some wood ash up here and rain. And the rain comes
Yeah.
and the wood ash will release potassium hydroxide into this limestone revel. And I think it will create a stone down here, a fake
You think
limestone
so?
down here.
Yeah.
Huh.
And if this is the case, we found a way to invent something like this. Because if you have limestone rubble and you put a fire on it and just leave it there and the rain comes and the potassium hydroxide goes down to the limestone rubble and it sticks into a hard stone, then you invented stone.
Right.
Huh.
It's not ready to. It's a few days old, and I would like to wait some more time. But if I do it with pure potassium hydroxide, it works.
Yeah.
Why shouldn't this one work?
Yeah.
And if it's true, I can create dolmens as well, not just menhirs, but dolmens from limestone, because you just put some limestone dust and gravel, and you put a layer of wood ash on it, and either you pour water on it or just leave it there to the rain do this thing and go back 2 months later and you have a pancake of limestone,
Yeah.
which you stand up and you have one of the walls of your dolmen. Ta-da!
Right.
I don't know. I would be surprised if it's not working.
How many
But
more
there is
days? Oh, sorry. How much longer do you want to wait to see if it's
a week,
successful? Can you
at least a week. Yeah.
Okay. Do you typically see that you see any reaction over time, or is it kind of, does it take several days and you don't really watch it at all? Is there an incremental progress in some of this?
I'm very impatient, so I have several of these just to try out what happens. I'm not very good at waiting, but I have just 2 of these remaining, so I have to wait for this. But it's getting harder and harder over time. But it takes a week or 10 days for limestone. For this, we have to slow down the reaction because it's minutes, 2 minutes. Sometimes, depending on the voltage, it's so fast that I cannot put it in this silicone mold because it.
Oh, really? Wow.
Yeah.
It didn't even occur to me that it could happen that quickly. That's amazing.
Yeah, like
It's
gypsum.
perfect for people that are impatient for it to
Yeah.
happen.
Yeah.
Can you tell me something about, so you kind of talked about the scoop marks. You've shown these little structures on this ceiling here on this roof. But there's another telltale sign, and that's like the little nubbins that stick out.
Yeah.
Through, right? Can you tell us a little bit more about how those little nubs happen and like why that's a telltale sign?
Yeah. I will. Can we show? I think I have a collection of knobs. So I always thought these protrusions are there. Let me show you a pyramid with these knobs.
If you
pyramid. Yeah.
If you don't mind, Marcel, while you're explaining this, could you? I don't think you've said it yet. So can you describe a little bit what modern concrete techniques are different very much from this ancient concrete technique where the water is actually being expressed out of the.
Yeah. Sure. Yeah. While I'm scrolling and showing one of these. Okay. So as far as I know, I am not a concreteologist, but as far as I know, concrete is a hydrate, meaning if you mix in the water, 50% of the water will remain inside the concrete, while these geopolymers are not hydrates. So you need, just a minute, where is the pyramid? Here we are. So you need water to create the mix, but the water will be pressed out as the chemical reaction runs down. Just I cannot talk and scroll.
Okay.
So here is the Menkaure pyramid, and these are artificial granite blocks, not limestone here.
Yeah.
So there is a condensation reaction, which means that when these particles are finding each other and creating a bond, a molecule or two molecules of water will be released.
Right.
And this water is absolutely not needed. It stops the reaction. If you don't remove the water, the reaction stops. I can show you something again. Sorry.
No, love it.
It's good. Yeah, and I'm thinking, George, he might go with some of even like those holes that look like it was drilled with some kind of high-powered power drill. That might be to actually express water out of this reaction.
So this experiment here is artificial limestone, but in a closed box, and it's more than a week now, and it cannot. It's not curing. It cannot became hard because of the water cannot. Because the water cannot escape. You see, I'm pushing it. Is it?
Yep. Yeah, we can see it. Yeah, we can see it.
It's
so
kind of a liquid.
Unless you take that cap off, there'll be no way it's going to solidify.
Yeah. Basically, it's. I don't know if how long will it do this, because eventually the limestone gravel pushes water out as it goes down.
Right.
But I think I hope it's a never-ending story, and this will never become a stone. It's like a liquid. But from this, I casted stones, and they are hard already. So you need to remove the stone, because if you don't, you will end up with this pudding, something like this. And with granite as well. So this is granite. And the fake granite I created, I used granite dust, water glass, and alcohol, whiskey, basically. And that mix will also release water under pressure. So if you have pressure, it will release the water. It's, again, because it's not a hydrate, it's a geopolymer, and geopolymer is not a hydrate, so every molecule of water is in the way and blocking the further reaction.
And the nubbins, like the placement of the nubbins where they are, like I'm noticing some of these in this image, like there's two. Do you think they did anything to direct where the nubbins would form, or do you think they just are fine with how they form where they are? Like I'm wondering if it was a casting, like did they leave like little holes on the wall of the casting wall so that the nubbins can pour out there, or how do you think they show up where they are?
First of all, they are always at the bottom, you see? And if it's not at the bottom, then the stone is rotated, because water will not do the favor to go walking up and leaving there. But I don't know. It's another mystery. Why are these so big? Some knobs are small. In Peru, there are super small. One thing I know already is that you don't always need these. Can you see my mouse at all? While I'm just no.
No,
you can't.
No, we see the picture that's being shown.
And now,
I see it.
It's on the picture. In the picture. Yeah. Okay. So these are huge ones here.
Yeah.
And then there is none up here. And it depends on I think they opened these holes when the stone didn't
dry.
Yeah. Because sometimes the surface is enough. If you cast it in a textile mold or something, you have evaporation, and evaporation will also remove water. But somehow this row had more volume, much more than the surface area. So the evaporation was not enough up here.
Do you think it may be also like the time of the year? If maybe there was more humidity when they put those?
It's or temperature. Yeah, sure.
Yeah.
Yeah.
That's a good
Yeah, I'm
idea.
just spitballing here because that, obviously they don't all have nubbins, but some do. So I wonder if that maybe is
Hmm.
a temperature
It's
thing.
it's also kind of I would agree that that's a possibility that the moisture content in the atmosphere. It's also interesting that on that I guess the fifth row where it has all those nubbins across the entire time, the three layers below that seem rougher. They don't seem nearly as smooth as that one. And I don't know if Marcel, if have you considered any theories as to what the casting is that they would have used? I mean, would it would it always be either uh, wood or large leaf, metal? What would be the casting that would fit around this,
Yeah,
or
what
would it
would
be
be the
other
form?
stones? I don't.
Hmm.
I'm just curious. You may not.
Animal skin, and these are the legs, for example. How about that?
I
It's a
mean,
cow.
I mean, possibly,
Let me
possibly.
show you. Let me show you a good
Hmm.
picture castings with a textile imprint. We are in Peru now. If I find it, yeah, no, no. This is Peru.
Oh yeah, you have to tell us about your little sword in the stone.
Yep.
Ha! So officially, this is wind and rain and
Uh-huh.
nature making these textile imprints on these stones. But
Hmm.
it's
Oh, look
textile.
at that.
It's textile.
Yeah.
So it can be anything. So Peru is a right place to check these, because if you go to Machu Picchu, there is a stone in Machu Picchu when you can see it was wood. That was this one.
Oh yeah, yeah,
This
yeah,
this is wood.
That.
yeah.
Yeah, definitely.
So you think that stone is hard enough, even cast, that it probably should not erode the way they're saying that it is, right?
No, 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 no. It's very hard. It's very hard.
Yeah.
These from water glass. This is Mohs scale 7 and 8. So no.
Yeah. So can you go back to your little swords? Because this was a interesting
Ah.
period when you were doing the little swords in there.
Well,
Because there's the legend. I'm not too familiar with it so much, but that there was a sword in a stone, and whoever could pull it out.
yeah, yeah, yeah.
So seeing this opened my eyes because I was like, okay, maybe that legend is true, and maybe they cast like you did here.
Yeah,
Like, what was
sure.
the? How did you come up with this idea?
Uh, I found an article about the real Excalibur, which is in Italy and is embedded in limestone. And I already knew that everybody can create artificial limestone over the years by burning the lime, watering the lime, and waiting for the atmosphere CO2 to make it back to stones. But it takes a long time.
Hmm.
Hmm.
But it's doable. So I thought that this this should be how to say that. I don't know. It was a quick idea to try to
Yeah,
do it.
Yeah,
Yeah,
yeah.
and I bought these swords on Temu. It's from China,
yeah,
Hmm.
and these stones are just the usual suspect: water glass,
Right.
some kind of wood ash. I don't know what kind of wood, and honey.
hmm
But now I can do it with limestone as well. So
yeah.
yeah,
That's pretty
yes,
cool. So
yeah,
I'll take,
they are beautiful. Yeah, one and only.
yeah. Um, being that we're all in IT and being as how we're probably all interested in technology, and I've seen you talk about AI and robots and things before, just to change the subject here a little bit. What what is it? So this is like ancient technology. So you're interested in the ancient technology. What is something new that possibly either just interests you or could relate to this in some form or fashion? Like what technologies are you looking at that you think would be life changing for us? Kind of like this casting is like that. These are big monuments that have withstood the test of time.
I'm not getting that. What are you looking for? Kind
I'm
of.
just wondering, like, what technology interests you today that's
You
new?
me?
That's
Oh,
yeah,
okay. Leaving the
yeah,
past. Okay,
yeah,
leaving
yeah.
the past behind.
Yeah, for a minute.
Okay. Yeah, being a used to be IT guy, I still keep my eyes on AI, and yeah, from time to time I'm posting about AI, but most of the times I'm getting a so hard pushback. Don't stop it! It's not.
Yeah.
We are not here for AI, so I stopped
Yeah.
it already. But it, but it's fascinating, these LLMs and the especially the way LLMs can be. Do your audience will understand this?
Yes. Yes.
Yeah,
Yeah.
the way
The language
LLMs
models. Yeah.
could be used for other types of languages like video stream and audio and driving a car. It's fascinating. So
Yeah.
it's mind blowing that people were doing things in the dark until LLM came out. This paper in 2017, I guess, with the title "All You Need Is Attention," and this is from 2017. And before that, or whatever you did in AI is just crap. And
Yeah.
from that paper, everything you do, it just works.
Right.
So it's fascinating. So
Do you use it for anything in this process? Like, has it been helpful for research or to ask questions on
as
some
a
of these?
user, yeah, I use ChatGPT and Grok and Perplexity and I don't know which is the fourth. And I usually try to come up with new ideas. But what I realized that they are just so close-minded, how to say, because if you ask them about artificial stone, no artificial stone. If you give them the clue that this is the way, oh, okay, that could
Yeah.
be, yeah, okay,
If you say, "Well, Marcell has this. What can you tell me about it now?" Then it's like, okay.
yeah, all the time. So when I'm trying to do something, I have to ask questions to mask my real goal, because if I tell Grok or ChatGPT that I'm investigating artificial stone, they just it's impossible. Forget it. So I have to rephrase it to look like an ordinary
It's
chemistry question.
it's
Yeah.
it's funny, Marcel. Sometimes I've been reading books and put them into Grok, and even though I'm physically holding the book and I say something controversial, they're like, "Oh, that's not in there." So then Marcel, I talk to it like I'm talking to a friend, and I say, "You're lying to me, Grok, and more importantly, you're lying to yourself." I'm holding the book. It's physically like I talk to him like it's a human. It's not.
Uh-huh.
And then Grok will apologize. Oh, I'm really sorry. I don't know
Yeah.
how I don't know how I missed that. My mistake. And then he gives me the thing. Like,
No. And sometimes it's so human. I'm asking things, and it turns out that he is understanding the context already. And oh, it's my ChatGPT or does this. Oh, it's mind blowing. You just invented something, and stop. You are just a chatbot. Stop it.
yeah, yeah.
Yeah, very good.
Where what is the next place you're thinking of taking a trip to? So you mentioned Peru, you mentioned Egypt. What are there any areas that you still?
Yeah, I definitely, I definitely would like to see Barabar Caves, because it's a huge. I think that I have no proof, but I think it's a huge. The whole mountain is a casting.
And where is
Oh,
it?
really?
Where?
In India.
India.
When there are the scoop marks nearby, there is Natron nearby, so everything is nearby, and it's from granite, and it was carved, and it has polished. It's polished. Like, okay,
Yeah.
one more thing. It's here. Let me show you this, if I can show it to glow.
Yeah.
I have this stone. I polished it with water glass. It's just photo glass. So everything is in place in Barabar to be an artificial mountain. But
Wow.
I cannot tell it from here. I have to go there to
Yeah.
see. This
And
is one.
Did
Sorry?
you mention that is there any ability to test a stone and get a chemical structure? I mean, yeah, I think you'd mentioned, I think I'd read before or heard from you say like there might be guano within, the actual casting or something like that. So obviously that's pretty clear cut. But is there a way to actually help confirm what you already know, that it really is a casting, or is it too difficult to try and prove that to, traditional mainstream?
Yeah,
What
yeah.
do you think?
Uh,
Like Jimmy, I guess. Are you and Jimmy still fighting? Do you guys get along?
I stopped fighting, but he's not right. He's
Yeah,
questioning chemistry.
that's right.
Okay, he's dumb.
I
I
got you.
think it's dumb to question chemistry. Oh my God, questioning.
Yeah.
Why don't he question gravity and
Right.
Yeah,
behave?
yeah,
I don't believe in gravity. Okay,
yeah.
Right.
okay. So what was your question? Sorry.
Oh no, it was
Oh,
about
how to test, right?
yeah.
The testing. Yeah.
How
Okay.
could you
Yeah,
how could you
can you
test and
convince an archaeologist, I
Okay.
guess,
Okay. So
on a stone?
archaeologists are going around with a handheld tool called XRF, which is a tool to tell the atoms in a piece of stone.
okay.
But this tool has several limitations. For example, it cannot see hydrogen, oxygen, coal, and sodium as a starter. Now, if anything has water glass in it,
Yeah.
it has sodium in it, and this tool will not show you sodium. So they think there is nothing in there because they don't know that sodium should be in there, and the tool tells them that there is no sodium, so it's natural. So with this tool, this XRF, they will never realize that they are looking.
Right.
Sounds like with that tool, it's the blind leading the blind. So the tool
Yeah,
can't see it, so the people are like, it doesn't exist, but we know it's really there.
yeah.
And
So and I think there is no easy way to tell the difference, because in this one and in artificial granite, the binder is also CO2, silicium dioxide,
right.
but just not quartz.
Yeah.
Quartz is silicium dioxide, glass is silicium dioxide.
Mhm.
They are both transparent, and if the glue is not quartz but glass, you cannot tell the difference chemically because it is chemically the same. You need a microscope to see the difference. But even if you use a microscope and you don't check the glue, but you check the grains inside, you
Right.
have to check the glue to
Right.
see it's a different glue, the different
So there's
binder.
no way even to date any of this. So if there's a carving and a casting, and you had them side by side, I guess I'm understanding there's no way to tell or age them or anything. Is that
That's
correct?
not true. I learned it a month ago or so that there is a technology called thermoluminescence, which works basically like this. If you put a stone outside in the sunshine, it will reset a kind of clock inside. Then you build it in a wall or put it in a pyramid, and
Mm-hmm.
it will be in the dark and cold. And there is the radiation from the what's the name of this background radiation? I don't know what's the name.
Not neutrinos, is it?
Yeah, something like this. And they
Okay.
are hitting the stone while in the wall or while in the pyramid, and
Mm-hmm.
they are exciting the atoms in there, and they are
Yeah.
pushing electrons up to higher layers. And this is and it's accumulating over time. And when you remove this piece of stone and put it in an oven and heat it, these electrons will go back to the previous position, emitting light. And
Mm-hmm.
this light emitted is in connection with the time period the stones spent in the dark.
Yeah.
So basically, you can measure the time when the stone was outside in a
Yeah.
quarry, carving, or something like that.
Yeah, it's if I may, Marcel says these you're right. These materials absorb radiation from their environment over time, trapping electrons in their crystal structure. So the longer an object has been exposed to radiation since it was last heated or formed, the more electrons are trapped, and you can
exactly.
age date it then from that.
Yeah.
Cool.
So it's
Wow.
possible, but again, archaeologists don't know about this, so it's not existing. It's not.
So I've got a silly question then for you, Marcel, about this. So aside from, well, this is how things are formed and this is how it occurred, this, that would be maybe controversial for what you're saying, but still, with you talking about casting and all of these megaliths possibly being, us humans being able to wrap our minds around how this could actually occur in real life with, regular people like us. Wouldn't that be just a marvel still in and of itself? It doesn't seem that controversial to me. Maybe I'm just being overly positive. Like, it's still an amazing feat, and
Sure.
everyone could be able to kind of really understand how cool all this is. But is it, people obviously, you're saying, giving feedback on your book, and we'll put that link in the description when we post it, are obviously getting great information. But there isn't any archaeologist that just won't even humor you about this idea?
No.
But you did say, go ahead.
I'm sorry. I talked to a geologist who told me this rule, kind of a rule, that if there is a color difference, there is difference in chemistry, and he was open-minded. But I actually, it was a surprise that he was so open-minded, and he told me a surprising thing, that not only archaeologists don't know how a stone was formed, geologists don't know or don't check, because they analyze stones by analogy. Meaning, this is the cheapest way. If it looks like granite, it is granite, and this one is granite because that one next to it is granite, and that's it.
Right.
It's
Guilt
the
by
cheapest.
association, identity by association.
Yeah, this is the cheapest way to analyze stones, and they usually do that. And by the way, they usually are right, because they are doing this for coal mining or oil fields. Or
I was going to say, a lot of sciences or a lot of engineering in an industry is not exact. And if they find a way to determine something and it works most of the time, and that's good for efficiencies and for industry and everything, but for understanding this planet and understanding how they work, it doesn't really meet that criteria to do that.
Mm-hmm.
That's very interesting. I have seen too that archaeologists are usually bound by universities, and there's all these things of tenure, and like it's a closed little knit group, so that's why they have a harder time looking at other things. But you know what, I'm seeing over the past year a lot more, I guess, truths coming out from various different places, things that are coming together to show the realities that people haven't noticed in the past, like you're noticing, and what you've done with all the experimentation. And I'm seeing that more people are being open slowly, like the doors are cracking open, like the veil is lifting. I think we're going to be seeing more progress, and people like you and others that are pushing all of this and throwing it in our faces that, look, here's what I'm doing, here's the experiment, you can do it yourself.
Right.
It really is. I think it's helping to make the world a more truthful place, a more honest place.
Yeah, over time.
You can say.
Yeah, but there is this saying that the old theories, how is it? Basically, all theories will die out with the old people.
Yeah.
So we have to wait to. No, okay.
Well, I like that you're not waiting. You're putting it all out there, so that's good.
Yeah. Because I don't have to worry about what happens if I'm not right. So what?
Mm-hmm. Right.
Yeah.
Well, that's a great point you bring up. You're wanting to do this simply, but importantly, to just share what you're thinking and share it with the world. And you feel like it's a viable thing. There isn't someone tapping you on the shoulder or financing you to say, well, this is how you need to shift this. Are there other collaborators that you either interact with on X or other places that kind of that you've sort of done any projects or anything with, or you kind of do your own thing and you sort of check in with other people that might look at the same thing?
I have my friends here in Hungary around me, and they help a lot. But most of the time they are just they are working in different areas and they don't care.
Right.
But as a brainstorming session, they are great. So, for example, this T-shaped pattern on the roof with the hole, I didn't realize that. There was a party here a few days ago, and one of the participants, I showed my pictures that, hey, this was in Egypt, and I think it's
Yeah.
casting, and he just pinpointed, hop, there's a T with the hole. Oh, we'll put another one. So the way of scientific research is this, to share it to the world, and either on X or personally, and
Yeah.
people will come up with new ideas, and I'm always learning from them.
Yeah, I think collaboration through the internet is huge.
Yeah,
You know,
yeah,
I've learned a lot by watching what you've got going, and I've seen other people chime in, and that really is a good way to. It's the ultimate test, right? Like, is Marcel pulling our leg here, or is it real
yeah, yeah,
science that's
sure, yeah,
happening?
yeah,
And people are doing it, like,
yeah,
and
yeah.
it's in
You
the
can
book.
say anything, but if there is a recipe to try out and it works or not,
Right.
this is the ultimate truth, not me, not my word, but this is the repeatable experience. And if you end up with a different result, okay, then we have to discuss and find out what's the difference in the
Mhm.
parameters. But anyway, at the end, we will find the common points, and we will learn something new.
Yeah.
So, Marcel, I want to ask you this: do you have a mission with this, or is this all just fun, or is it a combination of maybe it was fun and now you're like, well, I've got this big thing that people need to understand that maybe others have done as well? But like, what motivates you at this point, with this Natron theory and with the castings?
Mm-hmm. I would like to create my main motivation here to learn more, first of all,
Mhm.
to understand more, and to finish this puzzle, because there is this mystery that how is it possible that we don't know anything about it, but people 2000 years ago, they knew. There is the proof, there is the roof. So what? Okay, there was a flood, and there was
Yeah, the
younger
mud flood.
dryas and
Right.
comet and blah, blah, blah.
Yeah.
But there is another mystery that the Roman people and Egyptian people were able to do that, and now we don't know anything about it. Not here, not in India, not in Japan. They have these
Mhm.
megalithic walls in Japan, not in nobody knows shit. How is it
That's
possible?
bizarre.
So maybe there was a blackout in our times, in a 1,000 years, or in a 1,500 years ago or something, clearing the memory of people. So with these experiments like this one, I'm trying to figure out the whole process of inventing this,
Yeah.
and find the answer to this question: how is it possible that we didn't rediscover it after what kind of tragedy? How long ago? Just 1,000 years ago or 1,500 years ago? I don't know.
Right.
So I think not only meteorites are missing from our history, but something is missing from the close history from a few 100 years ago or a
Hmm.
1,000 years ago. Something is missing,
Yeah.
Yeah.
and by knowing all this from the beginning, how to invent it by mistake and
Yeah.
go with the technology and improve it, I think we can find the answer to this one. And this is a question nobody is asking.
Yeah.
So if you go back to that roof in Egypt, this proves that the casting technology until was not forgotten until this temple was built, which is 2,000 years ago or something. So it's not
Yeah.
the pyramid builders who did this. This is
Right.
several. There were like 32 dynasties in Egypt or something. So
Yeah.
32 dynasties after the pyramid builders, they still knew how to cast stone.
Yeah.
But now we don't know. what happened and when.
And just if just a couple generations don't practice this, or if
That's
you're an
enough.
artist of
Yeah.
this, that's enough then to just, especially
Yeah.
if you don't have any documentation.
Okay, but when and how it happened that everybody stopped building huge construction buildings? Why?
It's a huge mystery. Yeah, like why was it like you said the knowledge just disappeared for some reason and that's why it stopped, or was there something else? It's just so bizarre that you had these periods of big megalithic construction and then now that there's nothing. Even today, like we have skyscrapers, but we don't have anything at all like that.
Right.
Yeah.
Right.
And if we stop building like skyscrapers for 1 or 2 generations, I think the third generation will be unable to do it.
Right.
Mm-hmm.
Right.
Even a pencil today, like think of everything that goes into making a pencil. There's not a single human being that can make a pencil. Like I've seen this many times. Like there's all these materials that go into it. Like it takes lots of industries to build a pencil, and it's like, okay, well, how is anything bigger than that going to go on if we don't keep teaching it and keep doing it?
Our civilization is already a magic, a miracle. Yeah. It's so fragile. It's so fragile. Oh God. Yeah. Once I was up in a tower to view the city of Budapest. Doesn't matter. Mm-hmm. And I was there and I showed the kids that I can turn on the lights of my car, a Tesla.
Yeah.
And from the tower, and it was there, down there. But God, this went to, I don't know, to Texas or to the Silicon Valley or something. This just one click of a button to turn on the lights. It went all around the globe and came back, and the magic happened. It's just magic.
Right.
Yeah.
A fragile magic.
Yeah.
Yeah, for sure. That's yeah. Is there anything else that you want to share with us that maybe we didn't cover that you feel would be interesting for the audience? It seems like we've covered a lot of ground, and I don't know if I'm missing anything that I can think of. You, Adam, you got anything?
No, I think I think I've covered I wanted to ask you the couple things that you already answered. So I would love to see if you'd be willing to come back, whether it's once a month or once every couple months, because I'd love to hear about your experiments as they continue, and whether it's agave nectar as opposed to honey that may end up winning out for you. I learned here it's less expensive, maybe like half as expensive, but it's not nearly as thick and viscous, I don't think, as honey. So I don't know if agave nectar would be possible. But anyway, no, I really appreciate you making time to talk with us, and I'd love to have you back. I'm sure George would too.
Yeah, definitely.
Thank you for having me.
See the progress.
Yeah. And I'd like to show my bigger projects if there is any. Yeah. So, okay. Deal.
All right.
Yeah, that's perfect. Well, then, if nothing else, we thank you, Marcell, for being here. If anybody has questions, send them to us or Marcell will put all your links out, and maybe we'll have a bunch more fresh questions for you at the next time we meet, and you'll have some exciting stuff to share.
Okay. Thank you very much.
Yep. Thank you very much. And both of you hang on for just a couple minutes, and goodbye, everyone.